Good morning, students. Till now, we have discussed different things in mechanisms, right from the basic definitions, differences, and the types of joint, link, pair, chain. In addition to that, or apart from this, the important thing which we have discussed in the last two classes about the inversion. So, inversion means what? What is the main purpose of inversion? And what are the inversions of the three different types of kinematic chain? If we recall, we have studied the three inversions in case of first type of kinematic chain, that is 4-bar chain. In the second type of kinematic chain, that is single slider crank chain, we have discussed about the 4 inversions which are possible. And the third type of kinematic chain, that is double slider crank chain, for which again the 3 inversions which are possible has been discussed in detail. In addition to that, the examples wherever I have quoted, for which I have just attached the animation video of the same. Now, today, let us start the straight line motion mechanisms. As the name implies, the mechanisms which will produce a straight line motion. So, as the name implies or indicates, the mechanisms that are being produced, that are being developed to produce a straight line motion. So, the easiest method to generate a straight line motion mechanism in any kind of mechanism is by using a sliding pair. I mean, one of the easiest method to generate a straight line motion which is required for us by using any mechanism, for any type of mechanism, is possible simply by using a sliding pair. So, sliding pair is the one in which the two links are having a sliding motion relative to each other. That is nothing but a sliding pair. So, the easiest way in any mechanism to produce a straight line motion is by using a sliding pair. But, however, having said that, the sliding pairs are not preferred in precision machines due to wear and tear. So, in order to overcome wear and tear, in order to overcome a wear and tear, the mechanisms in which the straight line motion is obtained by using the turning pairs. It means it is very easiest method. By using a sliding pair, one can develop a a mechanism in order to produce a straight line motion. However, due to wear and tear, especially in precision machines, the straight line motion is obtained by using a turning pairs. Therefore, the mechanism in which a straight line motion is obtained by using turning pairs is called as a straight line motion mechanism. Basically, we have a different types of straight line generating mechanisms. They are broadly classified into two categories. One is the mechanisms which produces exactly a straight line motion, and second category is the one where the mechanisms in which they approximately produce a straight line motion. Based on this, the straight line generating mechanisms or producing mechanisms are two categories. One is exact straight line motion mechanism, under which we can have the three mechanisms what I listed. One is Peaucillier mechanism, second one is Hort mechanism, and third one is Scott-Russell mechanism. In all these three types of mechanisms where the motion is exactly a straight line, therefore these three mechanisms are said to be or exact straight line motion mechanisms. Then the second category, as I said, it is approximate straight line motion mechanisms, under which again we have three mechanisms. One is Watt mechanism, second one is Gross-Hopper mechanism, third one is Roberts mechanism. So these three mechanisms in which or with which we can produce approximately a straight line motion. Like that, this is the broad classification of the straight line motion mechanisms. One is exact, the another one is approximate. In exact straight line mechanisms, there are three. One is Peaucillier, second one is Hort mechanism, and third one is Scott-Russell mechanism. Second one is approximate a straight line motion mechanism, under which we have Watt mechanism, Gross-Hopper mechanism, and Roberts mechanism. These three mechanisms will produce an approximate straight line motion, whereas Peaucillier, Hort, and Scott-Russell mechanisms will produce exactly a straight line motion mechanism. But having known the overview of the straight line motion mechanisms, first of all, one should understand what is the basic principle of a straight line motion mechanism. In order to understand the basic principle of a straight line motion mechanism, let us consider the point O on the circumference of a circle with the diameter OP. Let us consider a point O on the circumference of a circle with the diameter equal to OP. Now let us draw a chord from the point O, which is shown in the figure by OA. OA is the chord which is drawn from the point O. Extend the chord OA and name it as the point P. And the chord OA is to be extended such that the product of OA into OB should be equal to always constant. With this statement, one can understood that the locus of point B will be a straight line perpendicular to the diameter OP. So you have to draw a circle and take a point O on it with the diameter of the circle is equal to OP. Now from the point O, you draw a chord, that is OA, which is shown in the figure, and extend the chord OA till the point B, such that the product of OA into OB should be always constant. Then the point B will be generating a straight line which is perpendicular to the diameter of the circle OP. So this is what the principle of the straight line motion mechanism. But how one can say that the point B will be exactly generating a straight line perpendicular to the diameter OP? So that can be proved by after extending the chord to the point B, in order to prove whether the point B will generate a straight line perpendicular to OP or not. To prove this, let us draw BQ, or drop a perpendicular from the point B by producing or by extending the diameter OP, so that the perpendicular drawn from the point B and the OP which is extended together will meet at the point Q. Now join the point A with P such that it makes an angle theta, because OA is a chord, and if I join the point P with A, that is join AP, then we find in the figure the two triangles. One is OAP and another one is OBQ, or similar triangles. From these two similar triangles, one can write the ratio as OA by OP is equal to OQ by OB. Means from the triangle OAP, OA by OP, OA by OP is equal to, from the triangle OBQ, you find the ratio of OQ by OB. These two are equal. Now, if I cross multiply, that is OP into OQ is equal to OA into OB. After cross multiplying, OP into OQ is equal to OA into OB. Now from this find what is OQ. OQ is equal to OA into OB by OP. Let us call this as equation 1. From the equation 1, the OP is constant as it is the diameter of the circle, because for any given circle the diameter is constant. Therefore, here OP is a constant because it is the diameter of this given circle. Therefore, if OA into OB is constant, then OQ will be a constant. So therefore, the point B moves along the straight path BQ, which is perpendicular to OP. Like this, one can prove that the point B will generate a straight line path perpendicular to OP. Have you understood? After finding the equation 1 from the two similar triangles, one is OAP, another one is OBQ. From these two similar triangles, if I find the ratio of, that is OA by OP is equal to, obviously in the triangle OBQ or from the triangle OBQ, that is equal to OQ by OB. Now cross multiply it, then find what is OQ, that is equal to OA into OB by OP. So that you call it as equation 1. If I examine or if I verify Or from the equation 1, one can say that for a given circle, the diameter is constant. That is, here the diameter of the circle is OP. Therefore, if OP is constant, then OA into OB will be equal to constant. Hence, when the product of OA into OB, which is the statement of the basic principle of a straight line, is constant, obviously the point B moves along the straight line path which is perpendicular to the diameter OP. In this way, one can understand the basic principle of a straight line motion mechanism. Now, let us move on to the first exact straight line motion mechanism. Now, though I said there are three exact straight line motion mechanisms, what are the three? One is Peaucillier mechanism, Hort mechanism, and Scott-Russell mechanism. But as far as the syllabus prescribed by VTU is, though there are three, for your syllabus, there is one exact straight line mechanism, that is Peaucillier mechanism. Now the figure which I have drawn should be drawn very neatly. Now with respect to the figure, now slowly I will explain what is Peaucillier mechanism. First of all, one should understand Peaucillier mechanism is a exact straight line motion mechanism. And this mechanism consists of a fixed link O1 and other straight links O1A, OC, OD, AD, DB, BC and CA are connected by turning pairs at their intersections, which can be shown in the figure, which can be seen in the figure, right? This mechanism is an exact straight line motion mechanism which consists of various links. One link is a fixed link, that is OO1. Remaining all links are straight links and they are O1A, OC, then OD, DA, DB, PC and CA. All these links are connected by means of a turning pairs at their intersections. The pin at point A is constrained to move along the circumference of a circle with the fixed diameter OP by means of a link O1A. Means with the help of link O1A, the pin at point A is constrained such that it moves always along the circumference of a circle with the fixed diameter of it is equal to OP. So now from the figure, one can write the geometrical relations are AC is equal to CB is equal to BD is equal to DA. All these four links are equal. Then also from the figure, OC is equal to OD. This is one more. Then OO1 is equal to O1A. Then only the point P will move along the circumference of a circle with the diameter equal to OP. So now I should prove that this Peaucillier mechanism will generate a straight line motion. Because I said this is one of the mechanism with which one can generate a straight line motion. Now how to prove it? It is to be proved that the product of OA into OB is equal to constant when the link O1A rotates so that the point B describes or generates or moves a exact straight line. Now in order to prove what I should do, I should join point C and D. So join CD. How to join CD? I should join the point CD such that it should bisect the AB at point R. Now after bisecting, I can find the two right angle triangles. One is triangle ORC. It is one right angle triangle. Now if I apply a Pythagoras theorem for this right angle triangle, one can write square of the hypotenuse, that is OC square, is equal to sum of the opposite square plus the adjacent square of the adjacent side. So that is OC square is equal to OR square plus RC square. OC is the hypotenuse and CR or RC is the opposite side and OR is the adjacent side. RC is the opposite side. So now if I apply a Pythagoras theorem for one of the right angle triangle, what is it? ORC. On applying a Pythagoras, OC square is equal to OR square plus RC square, sum of the squares of the opposite and adjacent side. That you call it as equation 1. Now another right angle triangle, that is BRC, is one more right angle triangle. These two are right angle triangles. So from the right angle triangle BRC, once again the square of the hypotenuse. Now in this triangle, square of the hypotenuse is BC. So BC square is equal to sum of the squares of the opposite side plus adjacent side, that is RB square plus RC square. So that you call it as equation 2. Like that I will get two equations by using the two right angle triangles. One is ORC, from which OC square is equal to OR square plus RC square. The another one is BRC, which is also a right angle triangle. On applying a Pythagoras, then with which we can write BC square is equal to RB square plus RC square. Both equations you name them as 1 and 2. Now I will subtract the equation 2 from equation 1. That is, I will subtract equation 1 minus equation 2. So if I subtract both the equations, that is equation 1 minus equation 2, first left hand side if I subtract the left hand side of both the equations, OC square minus BC square, that is equal to, now if I subtract the right hand side of both the equations, here this is plus RC square. If I subtract, this plus will become minus, then plus RC square minus RC square gets cancelled, then it will be left with OR square minus RB square. Now OR square minus RB square is in the form of A square minus B square. So what is A square minus B square? A plus B into A minus B. So that is equal to, now in that way here A is OR, B is RB. So A plus B means OR plus RB and A minus B means OR minus RB. Now further, that is equal to keeping the first one as same, that is OR plus RB into OR minus RB is also equal to AR. Because from the figure, OR plus RB is equal to OB. That is one thing. And RB is equal to AR from the figure, one can write. Then OR minus AR is equal to OA. These are the three equations or three things which we can list out from the figure. What is from the figure? OR plus RB is equal to OB. And RB is equal to AR because exactly you bisected. So therefore AR is equal to RB. And one more, OR minus RA will be equal to OA. With this Now what I do, in place of RB, I will substitute with AR. Now left hand side as it is OC square minus BC square, that is equal to, now on the right side OR plus RB, just now I told it can be written as OB, and OR minus AR can be written as OA. Now in the above equation, or in this equation, OC and BC are of constant length. That is what earlier I told, geometrical expressions from the figure. OC is equal to BC. OC and BC are of constant length, right? Therefore, the product OA into OB remains constant. So, left hand side in which OC and BC are of constant length, no change in the length. So, therefore, both are of same length or constant length. Therefore, the product OA into OB remains constant. So, when the product OA into OB is constant, right, according to the principle of Peaucillier mechanism, the point B will traces a straight line path perpendicular to the diameter AP. Now see in the figure, from P, if the point B moves, right, then it will be exactly perpendicular to the extension of the diameter of the circle OP at point Q. So now if I look at the dotted line BQ, or that is the path of the point B, it will be exactly a straight line. Like that, one can prove that the product OA into OB is equal to constant. If it is constant, obviously the point B will generate a straight line path which meets at point Q by extending the diameter OP of a circle. So this is a Peaucillier mechanism. So what are the two things you must remember? Peaucillier mechanism is an exact straight line motion mechanism, and what it does, or what purpose it is being used, in order to generate a exact straight line motion. So whenever you need to have a straight line motion mechanism, so one can use or adopt a Peaucillier mechanism. Then second one, classification, approximate straight line motion mechanism. Once again, though I listed out Watt mechanism, grasshopper mechanism, Roberts mechanism, as far as the syllabus is considered, so there is only one approximate straight line motion mechanism, that is Roberts mechanism. So Roberts mechanism is an approximate straight line motion mechanism. And if I look at the figure which is drawn, it is a forward chain with points O and O1 are fixed. Now in the mean position, or in the average position of the mechanism, mean position of the mechanism, this mechanism is in the form of a trapezium. OABO1 is looking like, or in the form of a trapezium with two non-parallel sides, OA and O1B. Strictly speaking, the two opposite sides in the trapezium are parallel. Opposite sides are parallel. So, but here two non-parallel sides, OA and O1B, are two non-parallel sides, but this mechanism is in the form of a trapezium OABO1, in which OA and O1B are two non-parallel sides. The links OA and O1B are of same length, but they are not parallel. Strictly speaking, trapezium means these two must be parallel, but here it appears like a trapezium with the two non-parallel sides. But however, the length of OA and O1B are same. Now, the another link, that is PQ, is rigidly attached to the link AB at its center, that is at point P. And the point Q traces an approximate straight line QQ dash in the displaced position. Means for any small displacement of the Q, all the points except O1 will occupy a new position. A will move to A dash, P will be P dash, B will be B dash, and Q will be Q dash. For any small changes, then the point Q will generate approximately a straight line path, which is denoted here in the figure by QQ dash. This is a Roberts mechanism. So not exactly the path of QQ dash is a straight line. Therefore, it is said to be a approximate straight line motion mechanism. So this is all about the two broad classification of straight line. One is exact straight line motion mechanism, for which one can give the example, that is Peaucillier mechanism, and the other category is a approximate straight line motion mechanism, for which one can take a Robert mechanism. Then after the straight line, then intermittent motion mechanism. Right, now taking intermittent motion mechanism. Now once again, the title reflects or implies or indicates intermittent, means not continuous. So therefore now I am going to discuss few of the intermittent motion mechanism. So what is the main purpose of intermittent motion mechanism? These mechanisms are used to convert continuous motion into intermittent motion. So that is why I said intermittent means not continuous. So intermittent motion mechanisms are used to convert continuous motion into intermittent motion. The mechanisms used for intermittent motion are: one is toggle mechanism, second one is ratchet and Paul mechanism, third one is Geneva wheel or Geneva mechanism. So the three intermittent motion mechanism. In all these three mechanisms are intermittent motion mechanism with which one can convert a continuous motion into a intermittent motion. Now the first one is a toggle mechanism. The figure which is shown, where this toggle mechanism is also called as a snap action mechanism, or it is also called as a flip-flop mechanism. As we all know that when we discussed about the slide crank mechanism, in slide crank mechanism, as the crank approaches one of its dead center position, either top dead center position or a bottom dead center position or extremities, whenever the crank approaches the extremities in a slide crank mechanism, the slider approaches to 0. So therefore the ratio of crank movement to the slider movement, almost or approaching a infinity, is proportional to the mechanical advantage. So this principle is used in toggle mechanism. What is that? In a slider crank mechanism, as the crank approaches or reaches one of its dead center position, the slider will also move, the slider will also approaches 0. So the ratio of how much the crank is moved to and how much the slider is moved, if I take the ratio of crank movement to the slider movement, then it will be infinity. So this principle is used in toggle mechanism. Now in the figure, link CD and CE are of equal length. Here AB is a crank and B rotates with respect to the fixed point A, and this is the dotted circle which is shown. The point B will generate a circle because AB is a crank. When you revolve a crank, it revolves about the point A, thereby it generates a circle because it is a rotating element. So, and BC is a connecting rod or a coupler, and the other two links are CD and CE are two other links which are of same length. Now if I resolve the forces at point C vertically, if I resolve, then F tan alpha is equal to P by 2. Because CD and CE are of equal length, then whatever the force that is acting at point P vertically downward, that is P, which is equal to half. Therefore, F tan alpha is equal to P by 2, from which one can write F, that is the force on the slider, is equal to P divided by 2 tan alpha. So this toggle mechanism can be found or used in toggle clamps, in riveting machines, in punch presses, in stone crushers. It is also used in switches and circuit breakers. So these are all the applications in which one can see the principle of a toggle mechanism. So riveting machines, punch presses, stone crushers, and in especially in electrical systems, in switches, in circuit breakers. So the toggle mechanism is used. This is one of the example for the intermittent motion mechanism. Now the second one is a ratchet and pole mechanism. So this is the figure which is shown. So in the figure, or the figure shows, or figure is a ratchet and pole mechanism, where you can see I have clearly named the different links 1, 2, 3, 4, 5, in which link 3 is a pole and link 1 is a ratchet. So in ratchet and pole mechanism, or a ratchet and pole mechanism is used in producing a intermittent rotary motion from an oscillatory or reciprocating motion member. Means here a oscillatory reciprocating motion member is a continuous motion. That motion will be converted it into a intermittent rotary motion. So that mechanism is called ratchet and pole mechanism. In ratchet and pole mechanism, what it does, it converts a continuous oscillatory or reciprocating motion into a intermittent rotary motion. So it consists of a ratchet wheel, which is 2, and pole is 3, as shown in figure. When the lever that is 4, link 4, carrying the pole that is 3 is raised, the ratchet wheel rotates in counterclockwise direction. As the lever carrying the pole 3 is lowered, then the pole 3 slides over the ratchet teeth. Then one more pole that is indicated with the number 5 can be seen in the figure. So that pole 5 is used to prevent the ratchet from reversing, because there may be chances of reversing back. In order to prevent it, a temporary pole that is indicated with the number 5 is used. These ratchets are used in feed mechanisms, in lifting jogs, In lifting jogs also you can see, in clocks mainly in our houses, and watches and counting devices. So these are all the examples in which one can observe or one can see a ratchet and pole mechanism. Now the third one is a third one or third intermittent motion mechanism is a Geneva mechanism or simply a Geneva wheel. Now as shown in the figure, it consists of locking plate, pin that is P, follower that is F. Now it is a intermittent motion mechanism, as I said already. It consists of a driving wheel D carrying a pin which engages in the slot of the follower, that can be clearly seen in the figure. So first point is, it is an intermittent motion mechanism, and what actually it consists of a driving wheel D, driving wheel which is indicated by the letter capital D, and this driving wheel D carrying a pin P which engages in the slot of the follower F, which is shown in the figure. During 1/4 revolution of the driving plate, means suppose if I revolve the driving plate by 1/4, the pin and follower remains in contact and hence the follower is turned by 1/4 turn. During the remaining time of one revolution of the driver, the follower remains at rest, locked in position by the circular arc. For the motion to be free from shock, the slot must be tangential always to the path of the pin upon the engagement. Right? So, what it consists of? It consists of a driving plate D carrying a pin which engages in the slot of the follower F. It is an intermittent motion mechanism. Now, if I revolve or during a 1/4 revolution of the driving plate, means whenever the driving plate D is revolved 1/4, the pin and follower remain in contact and hence the follower is turned by 1/4 turn. During the remaining time of one revolution of the driver, the follower remains at rest, locked in position by the circular arc. In order to motion free from shock, the slot must be always tangential to the path of the pin upon the engagement. It means that the angle O1PO2 will be a right angle, which can be seen clearly in the figure. So always, in order to be free from shock, the motion, the slot must be tangential to the path of the pin. Means geometrically or mathematically, the angle O1PO2 will be a right angle. So this mechanism is used in preventing overwinding of mainsprings in clocks and watches. So the clocks and the wrist watches which we wear, so in order to prevent the overwinding of the main bearings, this mechanism is being used. And similarly, in order to feed the film roll in early motion picture projectors, nowadays it is not there. So in olden days, in early motion picture projectors, in order to feed the film roll, this mechanism is being preferred. And also for indexing of the work table on a machine tool, so this mechanism is used. So these are the certain known applications in which a Geneva wheel or the Geneva mechanism is being adopted. So that is in order to prevent the overwinding of the mainsprings in wall clocks and as well as wristwatches, and to feed the film roll in early motion picture projectors, and indexing of the work table. So indexing of the work table on a machine tool. So these are the three intermittent motion mechanism which we can. So this concludes the today's class, where today, if I summarize what are all the things that we have discussed. First, I told what are the types of straight line motion mechanism, broad classification. One is exact, another one is approximate. So how many types of exact straight line motion and how many types of approximate straight line motion mechanism, in which, as far as the syllabus is considered, we have discussed with respect to your syllabus. So only we have one exact straight line motion mechanism, that is Peaucillier, and one approximate straight line, that is Robert's mechanism. Later, I just explained the intermittent motion mechanism, where we have discussed the three types of intermittent motion mechanism. One is toggle mechanism, and next one is ratchet and Powell mechanism, and Geneva wheel or the Geneva mechanism. So, as far as this is considered, where you need to draw the diagrams neatly and you need to explain with respect to diagram, first of all, what kind of mechanism it is and what it consists of and how it works and what are the applications. So, these are the 4 points where you must be written with respect to the figure, because these mechanisms are always, whether you take your IA examination or a end examination, the type of questions to be given or to be framed with respect to the mechanisms will be always a sketch and explain type. So therefore, one should be thorough with first neat diagram, second what type of mechanism it is, third what actually it consists of, and fourth how it works, how the mechanism works or working principle, and list some of the applications where these mechanisms are being used. So this concludes the today's class. Thank you.